Welcome to this comprehensive scientific lecture on how to prepare a research proposal for grant applications using artificial intelligence tools. Over the next 16 minutes, we will explore the systematic approach to leveraging AI in crafting competitive grant proposals. Research funding has become increasingly competitive. Success rates for major funding agencies like the National Science Foundation and National Institutes of Health often fall below 20%. In this challenging environment, AI tools offer researchers powerful assistance in developing stronger proposals. The traditional approach to grant writing involves weeks of manual literature review, outline development, and iterative writing. The AI-enhanced approach allows researchers to complete these tasks in a fraction of the time while maintaining or even improving quality through systematic analysis and optimization. The first critical phase in any research proposal is conducting a comprehensive literature review and identifying research gaps. This forms the intellectual foundation of your proposal and demonstrates your understanding of the field. AI-powered literature review tools can analyze thousands of papers in minutes. They map the research landscape, identify clusters of related work, and most importantly, highlight gaps where research is lacking. The visualization shows how AI can identify unexplored areas at the intersection of established research domains. Modern AI tools use semantic analysis to understand the conceptual relationships between papers, not just keyword matching. This allows for deeper insight into research trends and opportunities. Machine learning algorithms can analyze citation patterns and publication trends to predict which research areas are gaining momentum and which are declining. This helps you position your proposal strategically. Natural language processing systems can automatically extract key findings, methodologies, and limitations from thousands of papers, creating comprehensive summaries that would take weeks to compile manually. Once you have identified a research gap, the next phase is developing a strong, testable hypothesis. I can assist in evaluating the feasibility and novelty of your proposed hypotheses. The hypothesis development cycle traditionally relies on researcher intuition and limited literature knowledge. AI validation engines can assess your hypothesis against the entire corpus of scientific literature, providing quantitative scores for feasibility and novelty. This helps you refine your hypothesis before investing significant time in proposal development. AI systems can compare your proposed methods against the current state of technology and methodology in your field. This prevents proposing approaches that are not yet technically feasible or that rely on unavailable resources. Some advanced AI systems use predictive modeling based on historical data to estimate the likelihood that your hypothesis will be confirmed. While not definitive, this provides valuable guidance in hypothesis refinement. AI can identify papers with similar hypotheses that you might have missed, allowing you to position your work as advancing rather than duplicating existing research. This is crucial for demonstrating intellectual merit. The methodology section is often the most technical and detailed part of a research proposal. I can assist in designing robust experimental approaches and identifying potential pitfalls before they become problems. This diagram illustrates how I can optimize a multi-aim research methodology. Each aim is broken down into discrete tasks. The AI optimization engine analyzes the timeline, resource allocation, dependencies between tasks, potential risks, and alternative approaches. This comprehensive analysis helps create a realistic and fundable project plan. Machine learning models trained on successful grant proposals and published studies can suggest optimal sample sizes, control groups, and statistical approaches to maximize the power of your experiments within budget constraints. AI algorithms can optimize how you allocate your budget across different aims and activities, balancing the need to demonstrate ambitious goals with realistic resource constraints. This is particularly important for multi-year proposals. Natural language processing systems can analyze papers using similar methodologies to identify common challenges and failure modes. This allows you to proactively address potential problems in your proposal, demonstrating thoroughness to reviewers. The broader impact and intellectual merit sections are where you articulate why your research matters. AI can help you identify connections to societal needs and emerging priorities that strengthen your case for funding. AI impact analysis tools can map your research to multiple domains of societal benefit. This visualization shows how a single research project can have radiating impacts across health, economy, environment, education, security, technology, society, and policy. AI helps you identify and articulate these connections that you might not have considered. Advanced natural language generation systems can take your technical research description and generate compelling narratives that explain the potential impact to both specialist reviewers and broader audiences. These systems are trained on successful proposals and can adopt appropriate tone and structure. I can analyze funding agency priorities, recent awards, and policy documents to identify how your research aligns with current priorities. This allows you to frame your impact statement using language and themes that resonate with program officers and reviewers. Machine learning models can analyze citation patterns of similar research to predict the potential for your work to generate high-impact publications and influence future research directions. This data strengthens your intellectual merit arguments. Even the best research ideas can be rejected due to poor presentation. AI writing assistants can help optimize the clarity, persuasiveness, and readability of your proposal text. AI writing optimization works at multiple levels. It analyzes sentence structure for clarity, evaluates argument flow for persuasiveness, and assesses readability using established metrics. The bar chart shows typical improvements researchers see when using AI writing assistants. These tools can transform dense technical writing into clear, compelling prose. Grant review panels often include members from adjacent fields who may not be familiar with specialized terminology. AI readability analysis identifies overly complex sentences and suggests simplifications that maintain technical accuracy while improving comprehension. I can map the logical structure of your arguments, identifying gaps in reasoning or weak transitions between ideas. This is particularly valuable for long proposals, where it is easy to lose track of the overall narrative arc. Different funding agencies have different cultural expectations for proposal tone. Some prefer conservative, data-driven language, while others value bold, visionary statements. I trained on successful proposals from specific agencies can help you match these stylistic expectations. Understanding how your proposal compares to competing applications and recent awards is crucial for success. I can provide insights into the competitive landscape that inform your positioning strategy. This competitive landscape analysis shows how your proposal positions relative to others in a two-dimensional space of innovation versus feasibility. Red dots represent high-risk, high-reward proposals. Green dots are incremental but safe projects. Yellow dots are innovative but may lack feasibility. And purple dots are feasible but not particularly innovative. AI helps you identify the optimal zone that balances novelty with practicality. By training on historical grant awards and rejections, machine learning models can predict the likelihood of your proposal being funded based on its characteristics. While not perfect, these predictions help you understand your competitive position and make strategic adjustments. I can scan recently submitted and awarded grants to identify proposals that are tackling similar problems. This allows you to differentiate your approach and explain why your methodology or perspective offers advantages over competing work. The qualifications of your research team matter significantly. AI benchmarking tools can compare your team's publication record, prior funding, and expertise to teams that have been successful with similar proposals. This helps you assess whether you need to add collaborators or highlight specific strengths. The budget is not just a financial document, but a strategic tool that communicates your project's scope and priorities. I can help optimize budget allocation and generate compelling justifications. This budget allocation diagram shows a typical distribution optimized by AI analysis of successful grants in a specific field. AI considers factors like labor market rates, equipment costs, material expenses, and travel necessities to suggest optimal allocations. The percentages are benchmarked against funded proposals with similar research objectives. AI systems access current pricing databases for equipment, reagents, and services to ensure your budget estimates are accurate and defensible. Underestimating costs is a common reason for proposal rejection, as it suggests poor planning. Machine learning can identify opportunities to reduce costs without compromising research quality. For example, it might suggest shared equipment facilities, bulk purchasing strategies, or more efficient experimental designs that require fewer replicates. Natural language generation systems can create detailed justifications for each budget item, explaining how it contributes to specific aims and why it represents the most cost-effective approach. This level of detail strengthens reviewer confidence in your planning. Every funding agency has specific review criteria. Ensuring your proposal explicitly addresses each criterion is essential for competitive scoring. AI can verify this alignment and suggest improvements. AI alignment analysis evaluates how well each section of your proposal addresses the specific review criteria. This heat map shows percentage coverage for each criterion. Green indicates strong alignment, yellow suggests room for improvement, and red would indicate critical gaps. The AI identifies exactly where you need to add content or strengthen arguments to address underperforming criteria. Natural language processing performs semantic analysis to verify that you are not just mentioning review criteria, but actually addressing them substantively with evidence and argument. Surface-level mentions are flagged for deeper development. AI systematically checks for required elements that reviewers expect to see, such as project timelines, evaluation plans, data management protocols, and dissemination strategies. Missing elements are highlighted for addition. Some review criteria carry more weight than others in the final scoring. I can analyze successful proposals to determine optimal space allocation across different sections, ensuring you emphasize what matters most to reviewers. Modern research is increasingly collaborative. I can help identify potential collaborators whose expertise complements yours and whose involvement would strengthen your proposal. This collaboration network diagram shows a principal investigator at the center, connected to collaborators from complementary disciplines. Green links represent direct collaborations, while red links show how collaborators themselves are connected, creating a robust interdisciplinary team. I can mine publication databases and funding records to identify researchers with complementary expertise and track records of successful collaboration. AI network analysis examines co-authorship patterns, shared interests, and complementary methodologies to suggest potential collaborators who would add genuine value rather than just prestigious names. This ensures authentic interdisciplinary integration. Machine learning models can evaluate potential collaborators, track records in team science, looking at their contributions to past collaborative projects, their record of completing funded work, and their publication productivity in team settings. Many funding agencies value diversity in team composition. I can help you build teams that span different institutions, geographic regions, and career stages while maintaining scientific coherence. This demonstrates broader community engagement. A realistic, well-structured timeline demonstrates that you have thought through the practical execution of your research. AI project management tools can help create timelines that account for dependencies and resource constraints. This Gantt chart-style timeline shows task distribution across 3 years with explicit dependencies. AI project management tools use critical path analysis to identify which tasks are on the critical path and where delays would impact the overall project. This helps you allocate contingency time appropriately and demonstrate realistic planning to reviewers. AI algorithms identify the critical path through your project, highlighting tasks that have no slack time and whose delay would push back the entire project. This allows you to allocate extra resources or build in contingencies for critical tasks. I can detect when you have scheduled too many tasks simultaneously given your team's size and resources. Resource leveling algorithms suggest timeline adjustments that prevent overcommitment and burnout while maintaining overall project feasibility. Reviewers want to see clear milestones for assessing progress, but overly rigid milestones can be problematic if research takes unexpected directions. AI helps you set milestones that are concrete enough to be meaningful, yet flexible enough to accommodate scientific discovery. All research involves risk. Rather than hiding risks, strong proposals acknowledge them and present mitigation strategies. I can help identify risks you might not have considered and suggest evidence-based mitigation approaches. This risk mitigation matrix pairs each identified risk category with specific mitigation strategies. Technical risks are addressed with alternative methods, timeline risks with buffer time, resource risks with shared facilities, and personnel risks with cross-training. AI analyzes similar projects to identify risks that commonly arise and mitigation strategies that have proven effective. Machine learning models trained on project outcomes can predict which aspects of your methodology are most likely to encounter problems. This allows you to proactively address these concerns in your proposal rather than having reviewers identify them as weaknesses. Natural language processing can mine the scientific literature for papers that encountered and overcame similar challenges. This provides evidence-based mitigation strategies and demonstrates that problems are solvable rather than deal breakers. I can run scenario analyses to evaluate whether your backup plans are truly viable. For example, if your primary methodology fails, will the alternative approach still allow you to achieve your aims within the time and budget constraints? This ensures your contingency plans are realistic. Modern funding agencies require detailed data management plans that address data collection, storage, sharing, and long-term preservation. I can help you develop comprehensive plans that meet evolving standards. This data lifecycle diagram shows the complete flow from collection through processing, storage, sharing, and long-term preservation. Each stage has specific requirements and best practices that I can help you articulate. The vertical arrows indicate that at each stage, data feeds into the long-term preservation system, ensuring no data loss. Different research domains have established data format standards. AI systems aware of these standards can recommend appropriate formats for your data types, ensuring compatibility with repositories and future analysis tools. Hundreds of specialized data repositories exist. I can analyze your data types and research domain to recommend appropriate repositories that will maximize data discoverability and reuse while meeting funder requirements. Data management policies are complex and evolving. AI compliance checking tools can verify that your data management plan addresses all required elements for specific funding agencies and institutional policies, including privacy, security, and intellectual property considerations. Before submission, comprehensive quality assurance is essential. AI tools can perform final checks that catch errors and inconsistencies that human reviewers might miss after weeks of intensive writing. This Quality Assurance Hub shows 8 critical dimensions that AI tools can automatically check. Grammar and spelling verification, citation formatting and completeness, figure quality and captioning, budget calculation accuracy, format compliance, page limit adherence, reference consistency, and internal cross-reference validation. Each check runs automatically, generating a report of issues to address. Large proposals often have information repeated in multiple sections. AI consistency checking identifies contradictions, such as different values for the same parameter in different sections, or timeline discrepancies between the narrative and Gantt chart. I can verify that citations are formatted correctly, that DOIs resolve to the correct papers, that author names are spelled consistently, and that you have not inadvertently cited retracted papers. This level of verification would be impossibly time-consuming manually. Grant application instructions often run dozens of pages with numerous required elements. I can create a checklist from these instructions and systematically verify that every required element is present and properly formatted. Now let us see how all these phases integrate into a complete AI-enhanced workflow that transforms the grant writing process from a daunting marathon into a systematic, manageable process. This comparison shows that AI-enhanced workflows can reduce grant preparation time by 40 to 60%, while simultaneously improving quality by 25 to 35% based on metrics like reviewer scores and funding success rates. The phases overlap efficiently, with AI handling time-consuming tasks like literature synthesis and formatting, while researchers focus on scientific content and strategy. As you use AI tools across multiple proposals, they learn from your preferences, writing style, and successful strategies. This personalization means the tools become more effective over time, providing increasingly tailored recommendations. The goal is not to replace researcher expertise, but to amplify it. AI handles routine tasks, pattern recognition, and comprehensive checking, while researchers focus on creative thinking, strategic planning, and scientific judgment. This collaborative intelligence approach yields better outcomes than either humans or AI working alone. As we embrace AI tools in grant writing, we must consider important ethical implications and establish best practices for responsible use. This ethical framework diagram highlights risks to avoid and best practices to embrace. Researchers must never plagiarize, must not over-rely on AI without verification, and must not misrepresent AI-generated work as entirely their own. Best practices include verifying all AI outputs against primary sources, maintaining authentic voice and vision, and citing AI assistance where appropriate. Ultimately, researchers remain fully accountable for all proposal content. The most important principle is that A. I should augment human intelligence, not replace critical thinking. Researchers must evaluate AI suggestions critically, accept what strengthens their proposal, and reject what does not align with their scientific vision. Institutions and funding agencies are developing policies on AI use in proposals. Researchers should consult their research office about current policies and disclosure requirements. Transparency about AI assistance is increasingly expected. As we look to the future, AI capabilities in grant writing will continue to advance. Understanding emerging trends helps researchers prepare for the next generation of tools. This future landscape shows 5 emerging capabilities. Real-time collaboration, where multiple researchers and AI work simultaneously on different sections. Predictive funding models that forecast which agencies are most likely to fund your specific proposal. Automatic optimization that iteratively refines proposals based on simulated reviewer feedback. Voice interface systems that allow researchers to dictate and edit proposals conversationally. And integrated review systems where AI simulates the review process before submission. Next-generation AI systems will work across modalities, automatically generating appropriate figures and diagrams from your text descriptions, ensuring visual and textual elements are perfectly aligned and mutually reinforcing. Future AI assistants will develop deep understanding of individual researcher communication styles, scientific approaches, and strategic preferences. They will provide increasingly personalized guidance that feels like working with an experienced collaborator who knows your work intimately. Let me conclude with a practical implementation strategy for researchers who want to begin using AI in their grant writing process today. Do not try to adopt all AI capabilities at once. Start with one tool for one specific task, such as literature review or writing optimization. Master that tool, evaluate its impact on your workflow, then gradually expand to other capabilities. Always remember that you are the scientist and the AI is the assistant. Your scientific judgment, creative vision, and strategic thinking should guide all decisions. AI provides information and suggestions, but you make the final choices. The quality of AI output depends heavily on the quality of your prompts. Invest time in learning how to ask good questions, provide appropriate context, and iteratively refine your requests. This skill will pay dividends across all AI applications. Develop a systematic workflow that integrates AI tools at strategic points in your grant writing process. Document what works and what does not. Refine your approach with each proposal until AI assistance becomes a natural part of your process. Studies of researchers using AI grant writing assistance show funding success rates improving from a baseline of 15% to between 22 and 28%. This represents a 46 to 87% improvement in success probability. Given the effort invested in proposals, this improvement can be transformative for research careers and scientific progress. Preparing competitive research proposals is one of the most challenging aspects of academic life. AI tools offer unprecedented support in this process, helping researchers develop stronger proposals more efficiently. However, these tools are most powerful when used thoughtfully as part of a systematic approach that keeps human judgment central. As you embark on your next grant writing project, consider how AI can augment your capabilities, and remember to maintain a critical and discerning approach to AI-generated content.